Welcome to Virtual Reunion. Thank you for joining our family science class. A few things to mention before the class begins. Please use the Zoom chat or unmute yourself to submit questions. A recording of this session will be available in the virtual attendee hub later today. This class is taught by Professor Heidi Elmendorf. Professor Elmendorf has been at Georgetown since 1999 as a faculty member in the Department of Biology. At this time, I will turn it over to Heidi for this hands-on hour of science.
Hello, folks, and welcome aboard. I think what we'll probably do, actually, if this is okay with everybody here, we'll give everybody just a couple of minutes. Oh, I can see an eager face. So let me just give just a couple of minutes for folks to show up, because I know at least in my world this year, this is like things being super on time. But if you're here and you'd like to unmute, particularly if you're like a smaller person and like a younger scientist, and you'd love to unmute and tell me who you are, I would love to know who's visiting us today, which scientists I have around. And I can see a couple of really small and eager looking faces here. So let me just give folks a couple of minutes. And I can see people are like entering the waiting room and being let in. So I'm not sure if everybody can see that, but I can definitely see that. So let me just give folks a couple of quick minutes. And let me just get myself going here on my end, make sure I have everything all set here. And I believe this is going to work for us. Okay, that's good. Okay, let's see here. Okay, friends, hello, welcome aboard. So if you've just joined us in the last couple of minutes, oh, look at this, wait, I have like kids here. This is like the greatest thing ever. And then I can see some parents of kids here also. Hello, everybody. My name's Heidi. And most of my days I spend teaching bigger kids, but I'm really happy to see some of the littler kids here with us today. So I'm going to put my name in the chat so everybody knows. I think like you can probably see it on my screen here, but my students often call me Professor E because my name's really long, but I'm super happy just to go by Heidi today. And I'm going to try my best. I'm going to try and look at the chat at the same time that we're going to be doing some science and things. I've got two different videos running. So in one of them, you can see me waving at you. And if you can see me waving, can you wave back? Oh, excellent. Okay, this is good. Great. So welcome aboard. I'm glad to have so many younger scientists with us today. This is good. We have a lot of science that we need to do. I also have a second camera though, and it's this one, and I'm going to wave in my second camera. Oh, I'm waving upside down. Can you see my hand in my second camera waving? Can I wave right side up? There we go. Okay, so my second camera is here looking at my lab bench. Are you all at a lab bench? Are you all in a lab right now? And if you're like, no, I'm not either. Look what's behind me. Can you guys see my microwave? I have a microwave and I've got like a refrigerator. So let me show you what I've got going for today, folks. So here we go. Hang on a second. I'm going to give us all whiplash. This is my kitchen because we're all at home, right? But watch this. This is my science bench. I got it all set up just like it's like in lab, except I got everything from my kitchen. So that's what we're going to be doing today. And if you folks have things set up there, then I'll have time and you can I'll give us time and folks can do their science at home. And if you are just here and you're going to watch today, that's okay, because I'll also share the whole thing about what I'm doing. So you can always whoa, look at this. The Fontana family there is ready to go. Well done, prepared scientists. I don't know about you, but normally when I was a mom, at least of a younger daughter, I would not have been this prepared in the middle of the week. So if you're like I would have been as a mom, then also it's completely chill and we'll share stuff and you guys can do it later. Are we ready to go? Are we good? Thumbs up if we're good. Okay, excellent. Oh my goodness, there's some big thumbs out there. Okay, this is good. Okay, if you've got kids with you right now, I'm actually sure the kids are probably more adept at stuff than the parents are, but go ahead and like type the kids' names into the chat for me. Because at the moment, I'm guessing that the names that I've got are like the parents' names, which is like, okay. And possibly I taught some of your parents, which is just going to be awkward, but. Hello, Kennedy and Cooper. Welcome aboard. Where's Kennedy and Cooper? I have Isaac. I have Vaughn, Eldon, and Thane. Mackenzie. Folks are in Michigan. Francis is here. Luca and Noah are here. Rory and Blake are here. Oh my goodness. That's like a whole class. Well, this is good because we have Lily's here. Lily, I'm in Virginia too. So possibly we're not that far apart from each other, Lily. Okay, well, this is good because we have a lot of science to do. So I need a lot of science help. So I'm glad that I have so many helpers. Where is everybody else? I know I've got Michigan. And I know I've got a Virginia buddy. Where else are folks from? Yay, Chicago. Fairfax, New York City. Oh, New York City. Crazy place. Maryland. I lived in Rockville, Maryland for many years, possibly nearby where my Maryland crew is from. A Connecticut group. Oh, this is good. Philly. Excellent. Okay, well, this is good. So this also makes us like scientists because you probably think of like science as like one person maybe hanging out like here I am in my kitchen. But science is normally done by whole teams of people. And now it's often done by people like all over the world working together. So I think we've just become a science team and I'm happy to have you on board my team. Okay, so let's get going. And I'm gonna take a minute here. I actually prepared a PowerPoint because I wasn't sure the ages of folks that were going to show up. And now I'm sitting here debating with myself about this one. What are the average ages of my kids here with us today? I know I've got one set of kids here. I've had, wait, somebody dropped it in, 10, 8, and 5. Tell me more about ages of kids. Okay. Oh my goodness. Okay, this is like tremendously exciting. My daughter's 25 years old, which is like a very big kid right now. So I'm really excited. So here's what I'm going to do. I'm going to steer this a little bit towards the end of doing and a little bit less towards the end of telling and explaining. But I also want to respect that I've got like 10-year-old and a couple 10-year-olds and a 14-year-old and a bunch of parents on the line. So I'll do some explaining along the way too. So the thing that I want to talk about today with everybody is actually, and this may surprise you, but it's actually the thing I taught a class on at Georgetown this spring. And so if you're a parent, this probably makes you an alum. And if you're an alum, then like think back to it. And this was a class I taught to seniors in the biology major. So this was like a pretty sophisticated group of students. And, but I think we can do the science here today together. And the thing that we talked about was this brand new discovery about how it is that cells organize themselves. And for the littler kids out there, you might not have even heard a lot about cells yet. But if you take a look at your hand and you kind of like think like, what are you made of? Have you ever cut yourself and seen blood? If you've seen blood, give me a thumbs up. Like skinned your knee or cut yourself, like everybody's got thumbs up. Okay, if you're like living life, you've got a thumb up at this point. Okay, so like we're made of all sorts of parts, right? You're made of hair and you're made of blood and things like that. But really what we're made of are cells, all of these little tiny components. Think about it like you're like in a big building and it's made of bricks. And every single one of those bricks for a building is like cells for our body. And what we're understanding now differently is how different cells are organized. And it turns out that what I teach my students and what the textbooks teach us about is a little bit outdated. And we're learning all these really cool new ideas. So all the ideas have to do with how it is that different parts of your body, different sorts of molecules, and by molecules, I mean things like, prime example here, Morton's salt, like just normal table salt, how those all get organized and how they interact with water. We're made mostly of water, So if we were to like take our body apart and be like, what are we really made of? About 3/4 of our bodies would just be water. So all the other stuff, because you don't even think much of water when you see yourself, unless you like spit or you sweat or you do something like that. But otherwise, we don't think of ourselves being made mostly of water. But it turns out we're mostly made of water. So here's what I want folks to try. The very first thing I want people to do is to think a little bit about water and how water works. And if you've never done this before, then here's a really simple experiment to get us up and going. And here's what I'm going to do. I'm going to take my camera, this guy over here, and I'm going to turn this camera, wait for it, sideways. Okay. So now here it is. It's just looking at, this is a pie plan. There's nothing fancy about it. It's literally just this thing I'm using as a flat surface that seemed about the right height for my phone. So if your parents trying this at home, anything really will work. You could put on top of your pie pan, even if you wanted to, like a coin. So where's my camera here? There we go. Like a nickel or a penny or something like that. And I'm going to show you something that everybody's seen, but probably hasn't thought a lot about. So here's the thing I'm going to show you. I'm going to take, I've got measuring cup and it just has water in it. Super unsophisticated experiment, folks. And I'm just going to put a little bit of water on my pan. I'm going to put a few drops. And if I was fancying in the lab, I might have like an eyedropper, but I don't have one of those at home. All I have is a spoon. Okay. So can folks see my little, what do we see about this water that I put on it? Did it run all over the place? And if you've got stuff, oh, I can see somewhere Rory or Blake is shaking their head. What do we see about the water? What would you tell me about this water if you were a scientist making, oh, I can see, wait, I gotta find a name here. Now I gotta like look back in my Isaac. I can see, Isaac, are you doing the experiment there too? Okay, so what happens when you put a few drops of water on something? What do you get? What does this look like here? This little, and if you want to just unmute, folks should just unmute. The thing I hate about Zoom is I can't even hear people breathe.
Okay, so what does it look like? It sticks together. What else?
It doesn't move that much.
It doesn't move that much.
Doesn't move that much, and it sticks together. The sticking together was a really important thing, right? It doesn't just spread out. Let me show you a slightly different thing. If I, instead of water, if I instead took some oil, so nothing really terribly different, right? And I just took my oil and I instead, wait a minute. Oh. This is me trying to do science at home, folks. And I instead did the same thing with a droplet of oil. So can we see my water still? It's my water here, a little bit of water. And I did my oil. My oil instead just, I mean, it still is kind of together, but it just kind of like flattened out there. See how it got all flat? And here's my water. My water is still like this lovely little like beaded bump. Let's see if I can like fix my camera view here a little bit. Okay. So I ended up with this like lovely little bead of water. So the cool thing about water is that water sticks to itself really well. Water and how it does or doesn't stick to all the other molecules in the world is about how life gets organized. So here's what I want to try out. We're going to try a couple of experiments to see things that do and don't mix well with water. So first thing that I'm going to do, let me grab myself a good container here to do this in. I'm going to set this camera up right now. done with this down low experiment. Okay, so I'm going to grab just a nice glass that I can work with. And if your parents watching at home, please note the sophistication of the fine Georgetown stemware. Very sophisticated here. Okay, so I'm going to take some of my water. I'm just going to pour it into a glass. And I'm going to take some of my salt and I'm going to mix it in. And what do we think is going to happen? Good scientists always have predictions. What's going to happen if I mix in salt into my water? Isaac, did you have a hand up there? Do you want to unmute and tell me what you think is going to happen?
The water's gonna evaporate.
The water's going to, goodness gracious, Isaac, that's like a very sophisticated word here. The water will eventually evaporate. That's true. If I let it sit around, that's definitely going to happen. What's going to happen immediately? So you can tell I poured my salt in, and I'm just going to stir it around. What do we think is going to happen? I can see some more hands up. Folks should just go ahead and unmute.
It's gonna dissolve.
It's going to dissolve. So I can put my salt in. I can stir it around good. Oh, I put a lot of salt in. I've got a bunch of air bubbles, but give it a minute in time here to get rid of my air bubbles, but it's slowly dissolving. So it's dissolving really nicely in that water. I'll give it a couple of seconds and it's all gonna, like, my little air bubbles will go away. Let's try something a little different. I'm gonna put water in. And I'm gonna go back now to my oil. And I'm gonna pour some oil in. Now, and I'll do my mixy thing again. So I'll do my mixing. What's going to happen?
They won't mix because water and oil don't mix.
Water and oil don't mix. So this is true. And this is actually a really interesting property about oil and water. So I've got my salt water, almost all dissolved. There's still a little bit of salt in there. But that oil, I can mix it up, right? But I get those beautiful layers. This is like salad dressing, maybe. I can see, let's see, I've got scientists out here doing some things. Caravellis from Chicago are getting, is that Francis there? Francis, my scientist?
Yes, this is Francis.
Francis, you're doing a great job mixing there.
Are they mixing together? Not really, huh?
They're not really mixing, right? And I mean, this I mixed really well, and I got like a little mixing there. There's some bubbles, but it really doesn't mix. You can like stir it forever and ever. You can stir it, Isaac, until like the water starts to evaporate, and it won't really get mixed. Whereas this stuff, a little bit more water here. Dissolve things out well. Salt water, I had so much salt, it didn't all quite go in, but it dissolved really nicely. So it turns out you can divide almost the entire world of molecules into ones that do mix with water and ones that don't mix with water. And I had a student who was having a hard time remembering these different types of molecules. And maybe this will help everyone remember it. So he said to me, he said, you know, Professor Elmendorf, he said, I think molecules are really like either cats or dogs. Do you guys have pets? No. Oh, okay. So I have cats. Cats hate water. So he said, I think some of the molecules in the world are like cats and they're hating water and they stay away from it as much as they can. I mean, we put them in the same glass. They can't jump out of the glass, but otherwise they're staying away from water. He said, and other molecules are like dogs. And dogs really like water. And that's like these molecules, like our salt. So salt likes it and oil doesn't. This turns out to be super important because your cells and your body has lots of salt in it. Your body also has lots of molecules like oil in it. So if those are kind of the two big categories, I want to talk a little bit about making things maybe just a bit more complicated. And then I'll do a little bit of like even some deep science explanation here. So if I did this right, I would have a third glass, which I don't. So hang on one moment, folks, and I am going to get rid of my salt water because hopefully we're all going to trust that it got mixed well. So hang on one second. Only 2 glasses. The disadvantage of not being in the lab. Limited amount of stemware at home. Okay, so here's what I want to show folks. Got this jar. This will probably, parents will probably recognize this. So this is rubbing alcohol. And it looks like water. Kind of pours like water, looks like water. Can pour it into a glass. Smells funny. If you were here, you'd be like, oh, it stinks. But otherwise it looks like water. So here's the funky thing. This turns out to mix really well with water. How do I know this? In here, this is mostly this particular type of alcohol. It's called rubbing alcohol or isopropyl. 70%, it's almost 3/4 alcohol, but the rest of it's water. So the bottle I bought has both alcohol and water in it. And they're all mixed together. You can't see anything different. I'm gonna put the lid on it here. I don't spill it. You can't see anything different. It just looks like water. It looks all mixed together. But we can do a little bit of a magic trick. And what I want to show you folks is I can get the water and the alcohol in here to separate, to behave a little bit like the oil and water did. What are the bets? What are the bets that we can do this? People think you can do this? I mean, they look pretty well mixed together. It's going to be a little bit tricky, right? Okay, let me show you how we're going to go ahead and do this. I'm going to take that alcohol, and for this, I've got to mix things up really, really well to make this happen right. So let me go ahead and pour this in carefully. Okay. I have a bottle here. This bottle, parents, there's nothing, this was like, I just ripped the label off of like a bottle, just something I can mix things up in well. And I'm gonna pour a bunch, about a half cup of my alcohol in. And remember, alcohol and water all mixed together. Couldn't see the difference. And I'm gonna do a trick with it. What I'm gonna add to it is I'm gonna add my salt. How much salt should I add? I'm going to add a big teaspoon of it. So if you've got all the stuff at home and you're able to do this, trying not to dump all the salt in my keyboard, but like salt. And so here's I'll use my other camera. There's a good teaspoon of salt there. And I've got that isopropyl alcohol, that rubbing alcohol. I'm just going to pour it in. And if you're like me, now you just got some of it all over whatever table you're working on, but that's okay. And I'm going to grab a lid. And I'm going to shake it. And if you don't have a bottle around, you can stir this. And I did this earlier. I just used my spoon and I stirred good, but I'm going to try and be dynamic here. And all I'm trying to do is mix that salt in with the water as much as possible. We already did this with the water and the salt, right? And it just got mixed in. Nothing exciting happened. I just dissolved the salt into the water. Everybody was like, yep, it dissolved. But here, oops, I'm just going to do that same thing. I'm just dissolving salt, but this time in the isopropyl alcohol, the rubbing alcohol. Okay. Then I'm going to pour it back into my glass. And again, you guys could do this all in a glass. I'm just trying to be dynamic on my end here. Here we go. So I added so much salt. There's a little bit at my bottom, right there. And otherwise, it just looks like that water when I added the salt, right? Let's see, wait. I can see, who's my Philly crowd? Mackenzie. Mackenzie, are you there shaking things well?
Yeah.
Good job, Mackenzie. Okay. So then I just poured it into a glass. I'm just gonna like watch this glass. And this is gonna be the really most unexciting things possible, folks, for a little bit. So you know what I'm gonna do with this glass? I'm just gonna set it aside. And we're gonna have to come back to it in a minute. But what's going to happen eventually, well, I'm not going to tell you. We'll see what's going to happen over time. So let me set the glass aside, and I'll come back and I'll pick it up in a minute. Let me see here. Let me get all my little devices and stuff together here. Okay. So one of the things that we're going to be doing here, and this is probably, I've given this away some, is we're going to see how salt can change how different molecules interact. So whether they mix together well or they don't mix together well. So rubbing alcohol and water mix together beautifully. But when I put salt in, I'm going to change that. And that's going to be important for us because that's one of the ways that your cells sort things out and separate them or let them mix together is based on whether or not there's a lot of salt around. So let me show you one other experiment. And what I've done for this one, and I'm sorry, folks, parents, if you're playing along at home here, I did not put this into the list of things that you needed because I decided at the last minute to add this little experiment in. So I'm just going to apologize ahead of time, but I'll show folks what I'm doing here. So I've got a little dish, and what I've got here, these are egg whites. So I just cracked, or an egg white. I just cracked open one egg and I separated it, and I've got an egg white here. And one of the reasons that I didn't put this on the list is I wasn't sure if folks really wanted everybody handling egg whites. So I'll show what this looks like kind of here normally. I'm going to add a little bit of water to the dish. And I'm going to add some of my egg white to that dish. Oops. Whoop, whoop, whoop. And whoops, wait a minute. Just when I thought I had everything together here, folks. Okay. And I'm going to go ahead and I'm going to mix this together. So I'm just mixing, 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 mixing. It's like a weird goopy thing in here. Try to get out. There we go. Okay. So get this goopy thing out. Error on my part. Okay, here we go. So it's all mixed together. I just mixed the egg white in the water. Nothing really exciting happened. Now it's dilute egg white. Okay, so here we go, folks. Here's going to be the exciting dramatic moment. I'm going to do my salt trick again. And now I'm going to add salt to this egg white in water. Just plain old salt and just plain old egg white. And I don't know if folks can see this happening. Let's see how this goes here, folks. But not only did I get salt in here, but let me see if I can do this right for you guys. The egg white itself is starting to look like it's kind of cooked. It's turning not just that creamy color, it's actually turning, try this again, it's actually turning into big clumps of egg chunks. It's starting to look like scrambled eggs.
Can you eat the scrambled eggs in there?
Wait, who asked me that question?
Raise your hand. Yeah, I'm Vaughn.
I'm Vaughn.
Hi, Vaughn. So, well, I'm going to defer to your mom about whether your mom really wants you eating stuff. But the answer would actually be, yeah. So this is now cooked eggs. And when we talk about cooking, we almost always mean we're cooking it with like heat. But it turns out you can cook eggs with acid or with salt. And all we've done is that egg white had a lot of protein in it. One of the reasons we eat eggs is people say, oh, there's a lot of protein in that egg. Well, it was there before, you just couldn't see it. It was all dissolved in the water. And all that my salt did was it took that protein in my egg white and it made it all clump together. And that clumping together, that's exactly the sort of thing that happens when you scramble eggs. You add some heat and all that protein clumps together and forms, let's see if I can get this with my good camera here. And it forms all of this nice, like clumpy looking egg whites. So these guys are all cooked. Here's like good clumpy.
Will lemon what?
Oh, wait, who asked the lemon question? Vaughn, is that you?
Will lemon what?
Yeah, so you guys, so you can do the same trick. This is a great question. You can change how the protein is in water, either by adding salt or by adding acid. So you could use lemon juice or vinegar, and that'll change it the exact same way. And the longer I sit here, oh, folks can see, but it really is starting to look like scrambled eggs here. There still is a lot of water, like the water didn't go away, but the bottom of it is all filled with these clumpies that are just like scrambled egg clumpies there on the bottom. And so I could change how that protein was. So think about it. If instead of a dish, this was a cell, and cells are filled with water, about 3/4, but also they've got all sorts of proteins. Proteins in your cells are the molecules that do all the work for you. If you ever feel tired, it's because your proteins are tired. But I could change how they are in relation to all that water. And you can do the same thing with acid. And the longer it sits there, the grosser and clumpier it looks. Okay, so we can have molecules that do and that don't interact well with water, but I also can change how molecules interact with water. I'm going to say this is not looking super exciting yet. We're going to wait just a little bit longer, and I'm going to come back and show you this trick that we did with the alcohol. But what I want to do before then is let's get some drama going here, folks, because we've got a couple of really dramatic things. I kind of got us going in a slow way. But if you came prepared today, then you should have some sort of a container. It can be a bowl. I'm using pie pans again, just because they're big and I'm trying to be bold and dramatic because I'm teaching. But you could use like, little containers or something. I've got milk. And I have a whole array of little food colorings. So I'm going to video this again. And if you've got stuff at home, then I'll give folks a minute to get some of their like stuff out. And then we'll jump on in. And what do I need for this? I've got my milk. I have some of my food colorings. A little hat of food colorings here. There's all my food colorings. Take all my little hats off. There we go. My food colorings in my pan. I've got my milk. Oh, and I have palm olive dish detergent. The palm olive part isn't important. It's soap. That's the only important part. And a Q-tip. Milk, soap, Q-tip, and some food coloring. Okay, I'm gonna move my little stuff out of my pan because that won't help. You can have any type of milk you want. I got 3 different types of milk because I'm like a scientist and I wanted to check things out. I can tell Rory and Blake have their milk there. Are you guys ready? Okay. Mackenzie? Good?
Yeah.
Okay, excellent. That's okay. Most of my students like are silent on screen too, it turns out. Okay, I'm just gonna pour some milk into my pan. And I'm not pouring a lot of milk in. Folks doing this at home, it's like you're kind of cheating a little on the milk, just enough to put on the bottom of your pan. If you put a bunch of milk in, it won't ruin anything. I was just trying not to use all my milk on my experiments today and save some for drinking later. Because this stuff you don't want to drink when you're done. Okay, and here's what I'm going to do. I'm going to go ahead and I'm going to put in a couple of drops of food coloring. And if you only have one color, that's cool. If you've got multiple colors, you can put them in anywhere you want to put them in. You can put in a bunch of drops. There's not a right or a wrong here. And I just put some of those drops in. And I'm going to look at them for a minute because I'm a scientist and scientists make observations. Well, so what do we see happening? See, folks are like doing this at home. This is like the most fascinating thing ever. I've got Vaughn and
Observing the milk.
okay, we're observing the milk. That is good. Is anything happening?
The milk is absorbing the color.
The milk is absorbed. Mackenzie, was that you, dear?
Yeah.
Okay. Yeah, the milk is absorbing it. It's spreading out a little bit.
Stir the things afterwards. Let's see what turns into.
He said, do we stir it?
No, just let it sit there. It's pretty boring, right? Mackenzie, you were making the best of like a bad job here, but like nothing's really happening, right? Okay. Are we ready for drama? Okay, here we go. So now I'm going to take my Q-tip and my soap, and I'm just going to dip my Q-tip in my soap. Like this is really nothing sophisticated. This is just like, and if you're like, I don't have a Q-tip, you can even just take like a thing of soap. Are we ready? Well, I get, see things are happening here. Okay. I'm going to touch my Q-tip with my soap on it right into the middle of where my food dye is. Ready? And I'm just going to touch the surface. You guys doing this at home? What is happening?
It's spreading.
It's spreading out, isn't it? It's like soak it in there and it just. I tried not to go completely nuclear with this at the very beginning. You can see like the colors, they're like popping up and kind of swirling around. I've got lots of colors now at the sides. I can take my Q-tip and Anywhere that I drop some soap, now I'm just literally just dropping soap from above. And every time I do this, I can get new ripples going out across the pan.
Professor E, we only had coconut milk, so we used that and it didn't work. Can you help us understand what the difference is between dairy milk and coconut milk that might change it?
So the thing that professors love most, and I mean this in all honesty, is when we're stumped. So I was fully prepared. So I know so little about coconut milk. So I was fully prepared to answer the question about skim milk versus whole milk versus heavy cream, and I can tell you that one. I'd have to know what's actually in coconut milk to like understand it. So what's happening here though? So let me get myself a fresh pan while I do this, and I'll like do it again while I chat through. And okay, there we go. I'll show you what it looks like on my end with skim milk though, for the Fontana family. And this might help to explain some of it. So the one that I just did was with whole milk. And if I do it now, try a little bit more here, with skim milk, there's a reason I started with the whole milk version. And that's because the skim milk version, put a couple of my like drops in here again, has just the same amount of water and it has just the same amount of protein. But what it has less of is fat. And the less fat that you have, the less oil that you have, the less dramatic the effect is. So I'm going to guess that the coconut milk has less fat in it. And that's possibly why you buy it, that and like vegan sorts of reasons. So I can get the same effect with the skim milk, but I end up with like, it doesn't give me so many, like it spreads it, but I don't get all these like endless bubbles.
So we have an update if you're interested. We
Data
did so
from the field.
So first we did it with coconut milk that's like really, really high fat, like from the can. Then we did Coke and that didn't work. Then we did coconut beverage, which is a lot of milk, and then it spread out in the coconut beverage.
Oh, so it was probably actually too much fat.
Yeah.
Fascinating thing. So what this is all about is soap, when you mix it with water, soap actually acts a lot like oil does. And I know we don't think of it that way because we think about soap like cleaning up oils and fats, but soap actually acts a lot like oil. And so the reason that you get that great spreading is all your food colorings, these guys are actually all mixed really well with water. If I put them into a container with water, I can just make my little pour a container here with water, and we'll make a good Georgetown blue, little Hoya blue, right? And it just mixes in really well. So these guys, so the color is wherever your water is going. And the soap, because it's like oil and oil and water don't mix, when you add that soap into your milk, it's actually chasing away all the water and trying to find oil molecules to hang on to. So if you've got a good mix of oil and water, you get all this crazy running around of like molecules. And I know like we like think of things running around with legs. So like, I don't know, give them legs. They're running around and the oil's trying to find other oil molecules, just like happened in my glass, and the water's trying to find all the other water molecules. So if you go too far, Fontana family, in either direction, it's going to mess it up. If all you really have is just water, soap and water don't do a heck of a lot interesting together because they just, you can make them sort of mix, but you get those bubbles forming. And that you get bubbles actually because water and soap don't mix very well. So those bubbles are a way of keeping the soap and the water apart from each other. And I haven't done this before, but wait a minute, hold on, we can do this. Okay, so now we have a hypothesis. Good Lord, the science is now going interesting places, folks. Now we have a hypothesis. The hypothesis is that if it's done with like something that's really oily, we're not going to get any of that excitement. So I don't have coconut stuff here, so I'm just going to go with like pure canola oil. So let's see what happens, because this goes badly. There's nothing like having an entire pie tin of oil in your kitchen hanging out just to see what happens. Okay, here we go. Ready, guys? This one's for you. So let's get ourselves some. Whoa. Okay. Can we just see a difference even to start here? What happened? Mackenzie, what happened here?
It's not moving.
It's not moving. Remember last time you told me it was all spreading out? Man, it's not spreading out this time. Okay, and that's I said that all those dyes worked really well with the water. Okay, here we go. So now I've got Q-tip soap, and I'm going to plunk it right into the middle of this. That's not very interesting or dramatic. Fontana family, does that resemble the early coconut milk experiment?
Sort of.
Yeah, we saw the same thing with it not moving at the start.
So I think my pan still has a tiny bit of water in it because I just rinsed it out, right? So there's like, but like you can tell it's just a whole different dynamic here. Yeah, so it doesn't really work very well if there's too much of the oil around. Good scientific discovery, folks. Okay, I'm like looking at my time here, folks. Let's do one of our big dramatic experiments here, because the other way, no idea where things are going. Hang on. Okay. Oh, look at this. Look what happened to my egg. It's like completely cooked. Just clumps of that egg white. This is taking us a long time. I'm going to ignore that for right now. Okay, folks, let's go ahead. One of the things that I promised that we would be doing here is I promised that we would be creating lava lamps. So are we ready for some lava lamp action? Yeah. Okay. Isaac is looking very excited about the lava lamp idea. So hang on, let me dump some things here quickly. Okay, I'm going to do my lava lamp action here, just in my tall glass. And here's how we're going to start our lava lamp action. So the key thing that I need for my lava lamp to work really well is, wait a minute, get this out here, is I want to use some baking soda. So if you've got your baking soda, you want to take a spoonful of it and just dump it at the bottom of whatever glass you're going to use. Hang on, sorry folks, I'm just going to like dry this one out here. Make it a little cleaner for us to see. Least effective glass in the universe right now. Okay. Oh, so I'm going to put like a good teaspoon of baking soda. You can put a little more, you can put a little less. It doesn't matter too much. right in the bottom of my glass. Okay, then what we want to do is give ourselves our oil, pour the oil in on top. And give yourself a good glug of oil. It should look kind of like this. Nothing very dramatic is going to be happening. And that's because that baking soda doesn't dissolve very well in oil. It dissolves well in water, but not in oil. So these guys don't mix very well. Okay. Then let's give ourselves some cool coloring. I'm going to take my food color and I'm going to put some drops of my food color in. And I'll hold this up here so you can see what's going to happen. And if you drop your food coloring in, it's literally just going to settle down to the bottom. And now all I've got is food coloring sitting at the bottom of my oil. Okay. Hang on a moment here, folks. Let me get the next piece of this up and going. Okay, and if we're ready, I'm going to go ahead and I'm going to pour now into the bottom of this. I'm going to go ahead and I'm going to pour some of my water. And we should see if we can get this going. Okay, hang on, folks. Just did this before. Why is this not going for me at the moment? Oh no. How is this not happening at this exact moment? A minute, folks. I think I ended up with a dirty glass here. Hang on a quick second and let me clean out my glass, because now this is like a sad statement about my science abilities here. Oh, shoot, folks, that was me. That was all my bad. I did this one wrong. Hang on a quick moment. I'll just change over here. It won't be quite so dramatic, but I'll do it in this container. I'm sorry, folks. That was my bad. I poured from the wrong
There's
container.
bubbles in my thing, and
Is it
every
going?
time
Is
it
it going?
coloring, it pops back up and does it again.
Okay, hang on a second here, folks. I realized I made a mistake on my end. I was supposed to add vinegar, not water. Oh, let me get this up and going here, folks. Hang on one sec. Sorry about that, folks. My haste to grab a container. I realized I grabbed the water and meant to grab the vinegar. So let me try that one again here. Okay. Gonna get my spoonful going here. I'm gonna pour my oil in again. These things happen in the land of science. Okay. I'm going to add my food coloring again. Food coloring. And sorry about that one, folks. And I'm going to add my little bit of my vinegar to this. Okay, here we go. Sorry about that. There we go. So I'm getting this fizziness happening. It doesn't look much like a lava lamp yet, so give it a moment. Oops, there we go. And I've got my droplets coming down and going back up again. Sorry about that one, folks. So I've got my, oh, there's like little tiny droplets here all over the place now. So I've got my baking soda at the bottom, which is giving me all these fizzy bubbles when it's mixed with the vinegar. It does work with water. It's just really slow, folks. And I realized I'd souped it up before and forgot to make that change with all of you. The oil makes things a little heavy, and that food coloring doesn't mix very well with the oil. So it stays as these little tiny clumps of food coloring. And they float to the top with all of the air bubbles around them. And then they float back down. They lose their air and they float back to the bottom. And they float up to the top, and then they float back down again, all the way down to the bottom. And you can keep this going as long as you can have lots of your baking soda and your oil and your vinegar, and it'll go for you for like a while. These are pretty good lamps. They're not going to last forever, but they'll last for a good long period of time. And you can make them big or little. Doesn't really matter. I'm going to make us a big giant one right now. We'll give us some blue food dye in it. And I'll pour some vinegar in here. And first you get this big fizzy and all your color just floats up to the top. But then if you give it a minute, all those little, whoops, there we go. All those globs fall back down, get some fizzy and rise, and fall back down again. And this ability to like stay separate, all of those little blue globs are staying separate, but they can go back and forth and up and down. Do folks have fizziness here that's working? Wow,
Yes.
good job. Isaac, I can see yours. If you've got it working, hold it up to the camera here, folks. They're recording this one.
You want to hold it?
Let's see if we can get, let's see if we can get a picture of all of us here with like all the excitement, like not spilled all over the laptops.
Are you ready?
Wow.
Mine's more of just a fizzy thing.
Yes.
Mine's not working that well. It's not.
Mine
Mine
stopped.
Oh wait, I see some bubbles going.
I think mine's really good.
Ooh, oh, Thane, yours is actually fizzing on my computer.
So there's kind of a trick to a good mixture, and eventually they just stop fizzing. Like my first glass that I did, it just stopped. But they'll go for a little bit, and you can always start them up again. So if they stop fizzing, add a little bit more vinegar, add a little bit more baking soda. Either way, whew, but I just added some more vinegar and I've rejuvenated my old one here. It's up and going again. So you can bring them back to life for a little bit until you've used up all of your, you can bring it back to life until you've literally used up all the chemicals in here. They go up and down. And if it seems to slow down, give yourself some more baking soda and give yourself some more vinegar, and it'll keep on floating up and down. This is actually, it turns out, how scientists think that cells are starting to behave, just like this big fizzy mixture that we're making. I think this one's slowing down too. And I'm like, no, don't stop. Let's add some more fizz. And add a little bit more vinegar and poof, we're off to the races again. And you tend to get a good burst and then things go slow up and down. There we go. Okay, folks, I do believe that that brings us to 5 o'clock and the end of our Georgetown Science Hour. But if you've got some cool tricks and your whole family wasn't here with you, feel free to show it to your family, maybe over dinner. You can pour some milk out, put some food coloring in with soap. You can make them a fresh lava lamp. Do anything you folks want to do. But it's been fun to be with you today. And I'm happy to hang around and I'm happy to answer any questions. But in the meantime, I'll toast everybody for joining me.
Could I add rubbing alcohol to my lava lamp?
You know, you definitely could add some and see what happens. I'm intrigued by that particular notion. I might not do it near a computer keyboard.
Ooh, that started it. It starts it up. Wait, I want it. I want it.
Oh, did it work? I love how we now have like an entire community that does science out of like wine glasses and things in the kitchen. This feels like an excellent start.
It just starts it up. It just starts it up really
Does it start it up with the alcohol?
Yes.
Okay. No, we have like serious scientists here. Okay, I'm gonna try it. I'm gonna see what happens over here. Your enthusiasm for the "it starts it up" got me a little bit hesitant, so I didn't add too much. Oh, look at that.
Oh my gosh.
You don't have to add more baking soda.
I have to add more. Yeah, I was gonna say sometimes adding more baking soda is a good starting point too. It's anything that's reacting with that baking soda, and the water will do it too. It's just the water doesn't do it quite as dramatically.
Oh, Mom, look at look at how cooked it is.
Super. Okay, you want to show her your egg tail?
Hey, folks, apparently they want a picture of all of us if we're good with like sharing off like a screenshot of when we all held up our lava lamps. So hopefully folks are super excited by the like showing off our lava lamps and doing Hoya science. Look at that. Okay, we got it, folks. Good job.
Thank you.
Okay, well, so do me a favor. Make sure that when you guys get a little bit older, you guys come to Georgetown so we can do science together, not just sitting here on Zoom, but like for real in the labs. So I can see some, I got parents rocking the Georgetown gear too. So this is excellent. Well done. And
Thank you.
it's been so much fun having all of you here with me today. And again, I'm happy to stay around.
Thank
I'm
you.
happy to talk to anybody.
Mom, look at now.
But Kennedy, Cooper, Isaac, Vaughn, Eldon, Thane, Mackenzie, Francis, Luca, Noah, Rory, Blake, Lily. It's been so nice having you with me.
Oh, we had one more question for you about
Yes,
the alcohol.
Oh, yeah.
What? Ours just looks like water.
Oh, that you tried the separating of? Yeah.
Oh, do we have to add food color to it? I guess I missed that.
No, so you didn't have to. Sorry, I just did this at the end. So it turns out that what happens with the salt is you pull the water out of the solution. And you can either add oil or some food coloring. And if you add it really carefully, you can see there's a line.
Do I see it? Yes, yes, it's working.
And so, actually, this is like a trick that folks use if you want to take 70% and make it 100% rubbing alcohol. You can what's called salt it, and it pulls all the water out. So what we've done now is basically pull out the 30%
Look how
of
many
it that
bubbles
was
are
water.
coming out.
And there's just pure water at the bottom. So if you were to take the stuff on top now off of this,
Yeah.
it would be 100% rubbing alcohol, not 70%.
Dark one.
Wonderful. Thank you.
You're welcome.
You, Isaac, really enjoyed it.
Oh, excellent. Isaac, thank you for joining today.
You say bye.
Bye.
Bye. Rory and Blake are like still hard at work doing science here, I can tell. And Francis looks like Francis is hard at work too. Francis and Francis's mom are hard at work. Hi, Jennifer. We have good adventuresome spirits here. I feel like Rory and Blake are about to take over their kitchen permanently for a science lab. Oh, Joseph, it's a great question. So the implication for ourselves, yeah. So I actually had some higher end stuff prepared, but then we had like a bunch of like younger kids here with us today. So I tried to emphasize the lower end. So so Joseph, you've probably heard about organelles in cells, like the nucleus and the Golgi and things like that. Am I like speaking a language that sounds at least familiar from somewhere in life? Okay, so so it turns out that most of our cells organization doesn't happen because of organelles, but it happens actually really much more along the lines of like all of the little droplets and things in your lava lamp. And actually, if you Google like lava lamp and cells, you'll find all these articles that are talking about how most of the organization is because of molecules clumping together and hanging out with each other, but not because they've got membranes around them and they're structured in organelles, but just because they are sticking together and not sticking very well to the water around them. So this idea about getting these globs that go, I feel like I added just a little bit too much vinegar and like baking soda at this moment, but these globs that we see here, this idea that like all of the food dyed globs, kind of the water and vinegar globs, and that they're not interacting well with the water, that's how actually scientists think our cells get organized. And this idea that it's not just like a fixed glob, but they kind of come and go and they break and then they coalesce and come back together again. And then they like split up into other smaller globs. So it's believed that our cells organization is really dynamic. And if we were to look into our cells, we'd see things that look a lot like this lava lamp. Obviously not food coloring and things like that, but the principle about that organization would be like this. Tons of globs kind of self-organized and moving around.
Thanks again.
So it's my absolute pleasure, folks. It was a delight to be able to see everybody today. And keep doing science. I think I don't have to tell the crowd who's still on here, like the science is just going to keep going. We're going to hang up and you guys are going to keep doing science, which is a good sign. So thanks, everybody. Have a good one. Bye, Rory and Blake.
Thank you. Thank you. Bye.
Thank you. Bye.
Bye. Bye.